Alright, so today we are talking about surface area of prisms and pyramids. So the surface area is the sum of the area of all the individual faces and bases. So essentially what we're doing is we are calculating the area of every single side of a prism slash pyramid, and then we are going to add all of that together to get the sum of the area, and that sum is going to be our surface area. So what this is going to look like on a prism is as follows. So first things first, I like to go in and kind of identify what all my faces are, and then I just go in and check them off one by one. So right off the bat, we have these two 6x6 squares on either end, on the front and the back of this figure. And then the other shapes we have these rectangles that run along the right, left, top, and bottom of this figure. So we have 4 identical rectangles that I've highlighted in green, and we have 2 squares that have been highlighted in yellow. So what I want to do first is I want to go ahead and just knock out those 2 yellow squares. And I don't really have a rhyme or reason for that. It's just my own personal preference. So first things first, what I want to do is I want to do the base times height of this square, which is 6 by 6. So since the area of a rectangle or square is base times height, and our base is 6 and our height is 6, we're going to do 6 times 6. 6 times 6 is 36, so the area of one of these squares is 36 centimeters squared. And I'm not going to write that label yet. I'm going to save that for my final answer. I'm just going to jot down the numbers for now. So the area of one of these squares is 36, and we have 2 of them, so I'm going to multiply that by 2. So our total area for our squares is going to be 72 centimeters squared. Now, our rectangles are next, and we have 4 of these rectangles, and they are all 6 by 12. So once again, since the formula for the area of a rectangle is base times height, we're going to multiply 6 times 12. When we multiply 6 times 12, we get an area of 72. So each of these 4 rectangular faces has an area of 72. So our area for one is 72, and we have 4 of them, so we're going to do 72 times 4, and that is going to give us 288 centimeters squared. Now, our last part is I want to add up the 2 squares and the 4 rectangles that we've added the area to, or that we've calculated the area for. So if I do 72 plus 288, then I will come to a grand total of 360. So 360 centimeters squared. And an important point here is when you're labeling these, make sure you do use that squared sign, because we are not talking about linear feet. We're talking about a square feet. So linear feet would be like this red line here. Think about measuring a string or anything like that, whereas linear feet or square feet would be we're measuring this area. So each square foot is actually a 1 by 1 square. So 1 foot would be like that, a straight line, and then a square foot would be a 1 by 1 square. Okay? So that's our answer to number 1. Now let's hop over to number 2. So number 2 is a little more challenging, mainly because we have a missing measurement that we need to find, but we'll get into that in a minute. So number 2, we have this lovely little triangular prism. And this one we have 3 different types of shapes, or 3 different shape measurements, I guess. So we have 2 triangles that are 8 by 12, meaning their base is 12, their height is 8. So I'll probably calculate the area of those first, but let's highlight the other shapes here first. So we have a 12 by 10 base down here at the bottom, and we also have a couple rectangles up here. And now we don't know the measurements of these rectangles yet. We're going to have to use Pythagorean theorem to calculate that, which we've used before, so it shouldn't be a total shock on how we do that, but we'll go through that when we get to the point of calculating those 2 green rectangles. So first things first, let's go ahead and calculate our 2 triangles. So the formula for a triangle's area is half the base time, let's redo that there. 1/2 base times height. And this triangle has a base of 12 and a height of 8. So we're going to multiply those together. 1/2 times 12 times 8, which is going to equal 48. So 6 times 8 would be 48. So that is the area of one of these triangles, and we have 2 of them. So what I want to do is I want to multiply that area of 48 times 2. Since we have 2 of those triangular faces, 48 times 2 would be 96. Now, the next thing I think we should tackle is probably this rectangular base, which is a 12 by 10. And once again, the formula for a rectangle is base times height. So we'll want to do 12 times 10, which would be 120. Now, there's only one of these, so we'll multiply it by 1, and that leaves us with a total of 120 units squared. Now, comes the challenging part. So what we have left is these lovely, lovely green rectangles here that we need to calculate the area of. However, we're missing our height for these. So we need to calculate this blue line here to figure out what our height is. And how we're going to do that is we are going to use Pythagorean theorem. And so Pythagorean theorem deals with right triangles, which fortunately enough we have one that I just highlighted in yellow here. And what Pythagorean theorem says is in a right triangle there are 3 sides, A, B, and C, and A squared plus B squared equals C squared. And the only side that's really set is that C side has to be the longest side, and it's always going to be opposite the 90-degree angle. So using our knowledge of Pythagorean theorem, what we're going to want to do is we're going to want to plug in our numbers from this yellow triangle. So we have a height of 8 for this one, and then we have a width, or a base, I guess would be a better term for it, of 6. So if we look, we have this whole side that's 12 here, but we only want half of that. So our side would actually be 6 for this yellow right triangle. So our next step is we need to plug in our values to the theorem. So we're going to have 6 squared plus 8 squared equals C squared. And C is our missing value that we're trying to get to. So 6 squared would be 36. Oh, why is it doing that? That's weird. I don't know why that's freaking out. Okay, well, this is going to take a trip over here where I can actually write. Alright, so 36 plus 8 squared would be 64, is going to equal c squared. Now, 36 plus 64 is 100, equals c squared. Then our last step is we need to take the square root of each side, and we end up with c equals 10. So, instead of our c up here, we're just going to write 10. So now we know those two remaining rectangles are 10 by 10. So they're actually squares, in fact. So if we do base times height, 10 times 10, we have 100. So each of these square sides are going to have an area of 100. And we, of course, have two of these sides. One on the right, one on the left. And so multiply that by 2, and we're left with 200. Now, our final step for the surface area is we need to add up all of our sides, our two triangles, our one rectangular base, and our two squares. So 96 plus 120 plus 200 would be 416, I believe. 416 units squared. And just another reminder, make sure you have that squared on your units to signify that it is in fact square feet, not linear feet. Okay, now into the surface area of pyramids. So surface area of pyramids can be messy. And the reason for that is that a lot of our stranger pyramids are going to deal with calculating apophthegms, which we're not really going to go into as in depth as you would need to in order to find the surface area of all these lovely pyramids. So we're going to focus on rectangular pyramids today. And you're still going to need Pythagorean theorem for a lot of these, but that's no big deal. We can handle that. So just like prisms, with pyramids, what we're going to want to do is calculate the area of every individual side. So in this square pyramid, we have an 8 by 8 base that I'll highlight quick in yellow. And then we have 4 of these congruent green triangular sides. So the ones that are going up to a point are going to be all our triangular sides, and those are all congruent. And the reason they are congruent is because this is a right pyramid, meaning it's going straight up, and that since the base is a square, then the 4 triangles would be congruent. So what I want to do first in this case is I want to calculate the area of our base just to get that out of the way. So we have a square base, and of course our base or the area for a square is base times height. So we're going to do 8 times 8, which would leave us with 64 meters squared. And there's only one of them, so I'm going to multiply it times 1, which is a totally unnecessary step, but I'm just trying to do the same thing every time in hopes that it will help you all. So 64 meters squared. Now, we need to calculate the area for one of these triangular faces. Now, the hard part is we are missing a measurement, so they did not give us our height for these triangles that we need right here. But they gave us the tools we need to get to that height. And what I mean by that is they gave us a right triangle that, if I separate it out, looks like this, and it has a measurement of 6 for the height, 4 for the base, and then we are missing our C measurement, or our hypotenuse measurement, the longest side, in terms of Pythagorean theorem. So we can use Pythagorean theorem, a squared plus b squared equals c squared, to solve for that missing side. And a is going to be 4, so 4 squared plus 6 squared equals c squared. And 4 squared is 16 plus 6 squared is 36 equals c squared. So we have 52 equals c squared, and then we're going to want to take the square root of each side, and we're left with c equals square root of 52. And now I'm going to leave it as square root 52. Since it is not a perfect square, I would rather leave it as that square root and deal with that. So c is square root 52, so our height is square root 52, and now our base for each of these triangles is 8. And if we remember, our formula for area of a triangle is 1/2 base times height. So 1/2 times 8 times square root 52, and that will give us our area for each of these triangular sides. So I'm going to punch that in my calculator, and we're going to end up with, I'm just going to call it 28.8 meters squared. And now there are 4 of these triangular faces, so we're going to multiply that number times 4. So 28.8 times 4, and we end up with 115.2 meters squared. Now our last step is to add our 4 triangular areas and our square base area, and when we add those together, we end up with 179.2 meters squared. Have a